Hello, I'm Holly Lindley, and I'm here with Chris Franklin. And Chris was the lead author for the 2007 report from the American Statistical Association called the Guidelines for Assessment and Instruction in Statistics Education. This is often referred to as the GACE report. The GACE framework that was integrated into that document really used the four phases of a statistical investigation: pose, collect, analyze, interpret, and it really laid out the developmental levels of what one can expect someone at level A, level B, and level C to be able to do within each of those phases. So in this MOOC, what we did, we certainly built a lot of our initial vision from the GACE framework.
Right.
I mean, it's been a very influential document in the field, and we tried to think about how we could restructure it and improve it from thinking about the research that's been done over the last decade. The field of statistics education has really done a lot more research over the last decade, and we know a little bit more about students learning, and we know some of the things that they attend to and what works. And so we created what we lovingly refer to as the SASE framework for supporting students' approaches to statistical investigations, and how looking at the four phases of the different cycles: the pose, collect, analyze, interpret, and then thinking about the three different levels, what you can expect students to be able to do at each of those levels. So we have that in a format that we're hoping can be able to influence teachers as they are doing their planning. And one of the things that Chris and I are going to take a look at is how we can actually think about designing learning experiences around a particular topic. And as Chris mentioned, we're going to take a look at the mean and think about how that actually can be used to improve statistics instruction. So the example that we're going to take a look at is thinking about the concept of the mean. And Chris is going to illustrate for us how you can think about different tasks and activities that can develop the concept of mean, and how what that looks like at different levels, at a level A, a level B, and a level C. So Chris, I'm going to turn it over to you, and let's talk about how this might develop.
Well, as I mentioned to you a little bit earlier, it was really when Johnny Lott asked that question, what is the mean, that was the light bulb moment for us as to, we as statisticians need to think about what do we want students to understand about the mean at the elementary level, the middle school level, and the high school level. So one of the things that I typically do with my students, and this is an actual task that I carry out with my students and with teachers, I call it a concept task, is I ask the question, what is the mean? And most typically the answer I get first is, it's the average. And so I'll say, well, what is the average? And then the next answer I typically get is, well, you add up all the observations and you divide by the number of observations.
Right. How you find the average.
How do you find the average? And, they may also say, well, it's the median or it's the center value. And that can lead to another discussion. So then the next thing I typically say is, well, let me rephrase it. Let me ask you two different questions. How do you determine the mean versus how do you interpret the mean? And then I think that really helps them to realize that they've given me the answer to the first question. They've given me the algorithm. But what I'm really more interested in is, how do I interpret the mean? What does the mean represent for me in terms of my statistical analysis? So what we try to do then is I try to help them go through these three different levels. Now, let me just mention, in the GACE framework document, we did not call the three levels elementary, middle, and high school. And we did this on purpose because we wanted to state these levels based upon where we felt like students and adults would be in terms of their statistical maturity. How far have they been able to develop with their reasoning skills, their statistical reasoning skills? Now, roughly, level A would be elementary.
Right. In the ideal world.
The kinds
of things that we would
B would be
in.
middle, C would be high school, level D would be college.
Yeah.
But even my college students now, come in usually at level A.
Yeah, they need that early beginning
They
foundation.
need that early beginning foundation. And in teacher preparation, this is really important.
Right.
If you're a middle school teacher, you don't need to start with level B. You need to start with level A.
Yeah.
But you also need to understand what's going to happen at level
After,
C,
right.
at after. And so I think that's what's really nice about this activity is that we can kind of take them through each of the 3 different levels. They can see how the interpretation of the mean develops in those 3 levels. But we also talk about how to develop the way we quantify variation from the mean
Yeah.
in each of these 3 different levels. So typically what we'll do is I'll take them through what I call the family size problem.
Mm-hmm.
So a good statistical question that you might want to ask your students is what's the typical size of a family today, or how large are families today?
Yeah.
And at level A, and now granted you would have to determine what exactly is a family,
Right.
which could take some conversation
Absolutely.
before you try to answer this. But if you think about trying to answer this question at level A, which is roughly elementary, you might have some snap cubes in front of a group of children.
Mm-hmm.
And so I talk about, let's say we've got 9 children sitting around a table,
Mm-hmm.
and they each have snap cubes. And so they take the snap cubes and they build a stack of the number of people in their families,
Okay.
one on top of the other.
Okay.
Okay? So I've got 9 stacks now
All right.
of snap cubes.
So in my family, I have, are we talking about children or are we talking about everybody in the family?
How many people are in the family?
Okay, so for my family, it's myself, my husband, and my 2 children. So I would have 4 snap cubes?
That's correct. You would
Okay.
have 4 snap cubes. Now, you're going to have at least 2 snap cubes
Okay.
because we're going to say if you're under the age of 18, there has to be a guardian.
Right.
Okay, so we can't have just one. There has to be at least 2.
Mm-hmm. Which restricts the range of your data set.
That's exactly
We know
right.
we're not
which is
going to have a 1.
That's exactly right. So a lot of people will say, well, why don't I have a 1 when I get to level B? And I sort of tell them. So the question I might ask then, we have these 9 stacks of snap cubes, so how might we examine the data of the different family sizes?
Mm-hmm.
Well, typically what we would expect is for the children maybe to order the stacks from smallest to largest.
Yeah, seems
Okay.
like a gut instinct
A
kind
gut
of thing.
instinct to do.
Mhm.
And one of the first things we would hope that they recognize is that the family sizes vary. And so at a very early age, level A, elementary, we want our students to start understanding this concept of variability in the data.
Mm-hmm.
So then, once they've noticed that the family sizes vary, I might ask them the question, well, what if we don't want to have any variation in our family sizes? What if we'd like for the family sizes to be all the same? And we might tell the children, this is your opportunity to get rid of that brother or sister that you don't really like having.
Don't tell my daughter
Or
that.
Or if you happen to be the only child in your family, your chance to gain a brother or
There you go.
sister. But in asking them that question, really what we're getting after, as you can see, is we're wanting to find the mean.
Mm-hmm.
Now, we don't call it the mean yet.
Right.
Okay, we're helping them to develop this idea.
Yeah.
So, how many people would be in each family? So, what you would expect them to do then possibly, a couple of ways they might do this. They've got 9 stacks of snap cubes. One way that I think at level A they might do this is they just take apart all 9 stacks.
Yeah, so each cube is a person.
Is right. Each cube is a person. So they're just going to take all 9 stacks apart, and then they start rebuilding 9 stacks to where they keep them even.
So they want 9 families and they want to
Have
take all of
this-
these.
right, and have them the same size.
Mhm.
I think that's one way that they might do it. The other way that they might do it, although I think this would be more probably upper elementary to middle school, is they take the 9 stacks and then they go from the tallest stack to the lowest stack and they start moving 1 cube at a time
Until they kind of level them out.
until they level them out. The
Uh-huh.
idea of leveling out. Okay? So once they've done that, they then can see what we call the fair share value. So what they've actually created is the mean. But the way that we want them to be able to interpret that at level A is that the mean is the fair share value
You're sharing all the people among 9 families.
among 9 families. That's exactly right. Now, what I find very interesting with my college students is that I will actually go through this exercise with my college students. And even though that I want them to develop the sophistication to be able to interpret the mean, let's say at level C or even level D, more often than not, they fall back on the level A interpretation of the mean. They very intuitively understand, oh, the mean is that value that would be the same.
Yeah.
If everybody had the same value,
right.
same thing, that is the mean. So the next thing we might do then is I might tell you that I've got 3 different distributions. So we also introduced the idea of a distribution. This is a big idea in the middle school standards.
Yes, absolutely.
And of course, ideally, we'd like to have it introduced at level A. But let's say we got 3 different distributions, and I tell you the fair share value is 6 for all 3 of these distributions. Now, one distribution I'll show them is the distribution where all the stacks have a height of 6. And then I'll show them that's no variability. There's no variability from the mean. I'll then show them a stack. It's usually a blue stack. And I'll say, now the fair share value is 6, and then I'll show them a red stack where the fair share value is 6, but the stacks have different heights. And so I'll ask them another question. Of these 2 stacks, which one is closer to fair? Which one is closer to the fair share value of 6? So I'm trying to get them to think about the variability and which stack has a smaller amount of variability.
Right, right.
Now, what's interesting is a lot of the students will actually look to see, does one of the distributions have more stacks that are of size 6?
Yes.
Which one of the distributions does? That's the red one. And they'll tend to choose that one. Well, that one has more stacks of size 6, therefore it's closer to fair. But that's kind of what I call looking at it in terms of a how many approach. How many stacks are of the fair share value of 6?
Right.
But if instead you look at the idea of, okay, which distribution would I have to move fewer cubes to level out to the fair share value of 6? You actually discover it's the blue distribution. And so then we talk about, well, that's more of a how much approach. And we then say, well, let's either way, I left this as an open-ended question, valid reasons for either decision here. But for our purposes, let's think in terms of how many cubes we have to move.
Right.
Okay, we're going to go with this approach. And they see very quickly then that it will be the blue stack because they can level it out more quickly. So we define something at level A called the number of steps until you reach your fair share value. The smaller the number of steps, the less numbers of cubes that you move, the less variability that you have. So that's level A.
Yeah. And what I liked about that is it was integrating not just thinking about mean as center, but thinking of coordinating that with variation.
And I think that even at the collegiate level, one of the things that we as statistics instructors see is that students will always think about the center, but the variability piece is one of the last descriptions of a distribution that they intuitively think about. We really want them to think about variability, flip it.
Exactly, I agree.
We want to think about variability before we think about center.
Yeah, it should be one of our key habits of mind that we are always really thinking about.
One of our key habits of mind is you always think about the variability component. So we need to introduce it at level A. So what happens then is we move to level B. And level B, we're still going to stay with the same family size problem.
Okay.
But what we're going to do now is instead of using these physical snap cube representations, we're going to move to a more abstract representation.
Okay.
And that's a dot plot. And, I've always kind of questioned how quickly we sometimes introduce dot plots to young children and expect them to understand what's going on.
Yeah.
Because that's really an abstract representation.
Right, because we're organizing it now on a number line.
That's right,
Yeah.
on a number line, and we're using like one Post-it note or one dot
Right.
to represent a family size
Yes.
instead of that physical representation,
Right.
which is very visual for them.
Right.
But once we've made that transition to a dot plot, what I will typically do then is I will show them the 3 distributions that we had before as dot plots.
Oh, so the snap cube
The
distribution.
snap cube distributions
And how that looks as
and
a
how
dot
that
plot.
looks as dot plots.
That's nice.
And I think that really helps them to make that transition from the physical representation
Yes.
to the abstract representation. Now, I will actually have them go through an exercise in class where I have poster board and Post-it notes where I tell them, okay, you've got 9 families, the fair share value is 6. Now, I want you to create a distribution for me where the fair share value is 6.
Uh-huh.
And I'll give them certain constraints. It can't be symmetric, or you have to have more values greater than 6 than less than 6. So I have all these different constraints I give them,
Yeah.
which is a challenge for them. But what we're hoping that they will discover is that they're looking to see where the balance point
Right.
is at 6 by having them go through this exercise.
Yep.
So we're trying at level B to take them from the fair share interpretation of the mean to where it's the balance point of a distribution.
Yes. Yes.
So then once they've gone through this activity, I will take them back to the blue and red distributions that we looked at with the snap cubes. And I will ask them, do you see that the fair share value is 6? Of course they do.
Mm-hmm.
And then I will say, okay, now how would you measure variability from the mean, your balance point, in this dot plot?
Yeah.
And basically what we work our way toward is the MAD, the mean absolute deviation.
Right.
Now before we do that, I develop with them the SAD, which is the sum of the absolute deviations.
Yeah. And just even thinking at the core, what does it mean to deviate?
What's it mean
What
to
does it
deviate?
mean to deviate from
That's
the mean?
right. Now what's really wonderful, now this works nicely here, is that with the blue distribution and the red distribution, they soon discover what their sum of the absolute deviations will be. I then ask them to relate it back to the number of steps that they had with the snap cubes. And what they see, of course, is that the sum of the absolute deviations is simply twice the number of steps.
Mm-hmm.
So hopefully they can see then how they have evolved with their measure of variability from level A
To
to
level
level
B.
B.
Right.
That's correct.
Yeah.
I ask them, now interpret the MAD for me. Well, they say, well, it's just the average distance of the observations from the mean.
Mm-hmm.
And I'm like, that's correct. That's the MAD.
Right.
Now, why the MAD is so important, I think, is that even though we don't use it in practice a lot, it's very intuitive for students and for teachers
Right.
to look at a distribution and think about finding just average distance
Yeah.
and working with absolute values.
And that's a core concept that gets introduced
That's right.
in
And
late elementary,
and
middle
late-
school.
That's exactly right. And then by the time they get to high school, when they're introduced to the standard deviation, which gets into all this squaring and taking square roots, and you always used to get lost in the computations. Well, they already know how to interpret the standard deviation
Right.
because it's essentially the same as the way we interpret the MAD.
Yeah. Yeah.
And that
absolutely.
is really such an important idea that by the time they get to a more difficult computational way of quantifying variability from the mean, they already know how to interpret the standard deviation.
Right, right, because they understand center, they understand deviating from the center.
correct.
They understand kind of think about the average.
That's exactly right.
How on average, how far do I deviate?
That's exactly right.
Yeah.
So what happens then is, once they've gotten through understanding the concept of the mean as a balance point at level B, and the way we quantify variability from the mean, that average deviation from the mean with the MAD, we go to level C, and really what we want them to understand at level C now is, okay, I have a sample mean. how close can I expect that sample mean to be to the population mean?
Yeah.
The population for which I want to make an inference and try to answer my statistical question.
Right.
Well, of course, what happens at level C then is you move into the standard deviation
Mm-hmm.
from the MAD, but then you also move into sampling distributions to where you can develop the concept of a margin of error.
Yes. Yeah.
And
so you're
that is-
thinking about the distribution of all the sample
That's
means.
exactly right, the distribution of all the sample means. And this is where our high school students are expected to go with the Common Core
Right.
standards.
Yes.
And to understand what that margin of an error represents, that tells us how close we can expect our sample mean to be to our population mean
Yeah.
if we have randomly sampled.
Right, right. And imagine high school students that are dealing with this who have gone through
Yes.
understanding from the levels A's and the level
Yes.
B, that their rich understanding of a sampling distribution.
It's incredible.
Yeah.
And this is all done through simulation
Mm-hmm.
and level
Which is
C.
also represented in the Common Core
That's
as
exactly
well.
right. And so, of course, by the time they get to college, and if they do take another statistics course,
Which we hope they do.
which we hope they do, people like me can reap the benefits
That's right, that's right.
of what they've learned at the high school level.
Yeah.
But in reality, it's essential for our students by the time they graduate from high school to understand these core concepts of margin of error and
Mhm.
p-values. This is what they're reading every day in the media.
Right, right. So having an
And-
understanding of what that
Right.
represents.
Is very important. So that's just an example of how we take students through the three different levels,
Mhm.
how we try to help them discover on their own the concepts of these key statistical ideas.
Yeah, yeah. Well, that's good.
And
Well,
this is all outlined in the GAZE document.
Good, good. Well, thank you very much. So we do have links to the GACE document as well as lots of different tasks and activities that we'll be exploring in the MOOC that give illustrations of what things you can do at different levels. And so we're hoping that the teachers and participants in this MOOC walk away with lots of different activities that they can think about developing concepts as well as exploring statistical investigations that really integrate those four phases and develop strong conceptual understanding across the three different levels as well. Good.
Okay.
Thank you.
Thank you.